So, Assalamu alaikum. Just continuing from the point which we had left in Lieutenant chapter lecture number 11. So, I'm just continuing from it. In this lecture, I will be just discussing the three types of systems: RLC circuits, RLC series circuits, that is overdamped, critically damped, and underdamped. And also, I will be just saying a few words about undamped also. All right. So, that there is no damping in this. There is no damping, that will be called undamped. So we were in this this page overdamped. So in this case S1 and S2 are going to be negative and real, that I already had told you. Right. So the next page is going to be this one. Yes. You see this is the fourth page. I specifically have marked it as fourth page. Right, so this is in the last page 3 I already have told you about the overdamped system. In this, alpha will be greater than omega, and in this means that these are the facts that C will be greater than 4L upon R square, and the roots will be real, and they will be S1 and S2 negative. So this is about the overdamped system, and then comes the borderline when alpha is equal to omega. That in that case the system will respond in critical damped situation. Alpha is equal to omega. If omega and alpha are equal, that means the root will be 0, and there will be just one root, that is minus alpha. If you are not convinced, then I can just show you again from my slide here, that this equal to this. What will happen? That the whole root will be just equal to 0. So then this will be plus minus 0 here. So it will be just minus alpha. So there will be no two roots. There will be just one root. In the case of critically damped situation. So our assumed solution in last time, but we had assumed it was A1 into e raised to power minus alpha t, and A2 multiplied by e raised to power minus alpha t. So the roots are coming here in the alpha place, and that is because this is going to be same. So both the terms are going to be same, and then this will become just a constant, A1 and A2. There are two constants. We had assumed that there are two constants, but it will just be reduced to single constant. So with two initial conditions, you just cannot solve. Have the solution of the equation different solution, because there are two initial conditions. Two initial conditions cannot be satisfied with this single constant A1 plus A2. So what's the wrong here? The wrong thing is that assumed solution is wrong. Right, so these are the things that which we have to learn from differential equation solution course, but this is definitely not a course for about the differential equation. So you will have just to understand or assume the things that they are correct, and this is the correct method of solving. The approach is correct because that is in line with the differential equation course. Alright, so just going back to this, the assumed solution, the starting equation, not the solution, the starting equation. So writing equation in terms of alpha, we can just write it these things in alpha, because r upon 2l, 1 upon r upon 2l is alpha, and 1 upon under root LC is omega naught. So omega, alpha and omega are equal, so this will also be written as alpha, and this will be written as 2 alpha, because there is no 2 in the denominator here. In the alpha there is a 2, so r upon L will become 2 alpha. That's why this has been replaced with 2 alpha. You see, just this 2 will go here, and it will become r upon L, so it will be 2 alpha. So alpha here will be replaced with 2 alpha here. Alright, then we just do a bit of rearranging here, and this term has been replaced with the two terms. this 2 has been replaced, and then this is written 2 times. So this is exactly the same equation, but just written in a different way, just to help to make the factors. So taking common from here, the derivative has been common taken, and alpha remains just here. So this I also remains here, because when you will take a derivative of I, it will become di by dt. So what can come out here from here? So it will can come out alpha. So it will make up this equation equal to this, that d of I, this term, upon dt, di by dt plus alpha I, and this is plus alpha I, and this will be also di. One thing which I have just missed out is that di, okay, this will become equal to f. This thing will become equal to f. Right. Hold a sec. I just show you from the book, but for that I will have just to pause the things. You see, we were just in this step, the same step which I had done on my paper. So this thing has been equated with f here, right? So this will become d of f by dt. The bracket will just be replaced with f, and alpha will with bracket alpha, and the bracket, the same bracket f. So it will become alpha. It will become alpha, and this is f. So it will become alpha f here. Alright. So what page I was on? Page 4. So this has been replaced with alpha f, this whole thing, and now I will to just show you the next page. And next page should be page number 5. So where is it? Okay, I will just take it out here from here. Material for chapter number 11. Now the chapter has been replaced. It has been split in two parts. So this is the material for lecture number 12, not 11. Okay, this is the 5th page. So it will become df of dt alpha f. Alright, so you can just see again from the page number 4. Yes, so this is f alpha f, and this is also f alpha f. Okay, so page number 6, no, page number 5. I was on page number 5. So we have a little left with, so we can just do it quickly. So it is just a first order differential equation. This becomes a first order differential equation, and we just try to follow the same steps which we had done last time with the RL circuit and RC circuits. So this will be equal to ln of f, and then there will be definitely the limits. Whenever you just integrate it, it will be just limits ln of d of f. So this is going to be the limits here, and because this term, the term here is dt. So you see, we have just arranged from this point. I have just taken alpha f from the left side to the right side, and then cross multiplied with this dt here, df here, so just symbol df here and dt here. Right. So then we have just integrated the things, integration here and integration here. So applying the limits of the variables, because it was dt here, so we have just applied, we will apply the limits in terms of t here, and we will apply the limits in terms of f here. So this is going to be ln f, definitely t is there, and this will be ln f time t is equal to 0. That's why this is 0 here. This has come from here, applying the limits, the minus sign between the upper thing, the variable, and the constant, the minus sign here and this minus sign. So because the t is just a t and the 0, so there will be nothing on the minus after minus here. the limits are applied here. So it can be just written as, because this is a constant, f of t is a constant, f of 0 is constant, and ln of f of 0 is also going to be constant, so it has been replaced with a1. And then mid of manipulation, because this is logarithmic exponential, so a1 can come in denominator and the ln is taken. So moving further, f becomes equal to a1. If we just take exponential here, e here and e here, so this thing will go in the exponential e. This minus alpha t will be coming in the exponent of the exponential e, and a1 will be just multiplied with on the left side cross multiplication, so f will become just this. So f1 is this, so we can just put in this value of f here. This f is going to be equal to this whole thing is equal to f, though, so we have just equated this f, the value of f which we have found here in here, equated there. So taking this e raised to power minus alpha in the denominator of this, so what will happen, this minus will become positive here, and alpha I and e raised to alpha minus will go, because we have just brought it in the denominator from the denominator, so it minus is just changed, and this I is just missing here. It should have been here, the I. This, just assume that this I is just written here. I have missed it out while writing this. I is here from the steps. You see from the book, this I is here in the book. So this is a very much d of uv kind of thing. 5, like, as this is a d, this is a product form u of v, because what is u and what is v? This is u and this I is v. So here we have taken u dv and here we have taken v du, right? And v involves this I here, so I just said that you should write I here. Assume it. If you just don't want to write it, then you should assume the I is here. So it has been written in the form of uv, d of uv, and integrating, so just to eliminate this derivative here, and it becomes e raised to power e raised to power I multiplied by e raised to power alpha t is equal to a1, and if we just integrate it, so it will become a1t, and then there will be a constant of integration that has been shown as a2. Taking out this it separate, so just we divided this e alpha t in the denominator here, and then we just converted the sign from alpha to positive alpha to minus alpha, just to bring it in the numerator. So this is it. So this is going to be the solution of critically damped when alpha is equal to omega naught. Right, so now this has been just done to find out the maximum value of this function it. So for maximum value of finding a maximum value, what you do is you equate the derivative of that expression equal to 0, and that's exactly what we have done here. We have taken a derivative here of d of it, this is I of t, so this is equal to 0, and then finding out going further, so this comes out that t is equal to 1 upon alpha. So that means it is going to be the time is going to be equal to 1 upon alpha, where it will take the maximum value. And what is going to be the maximum value? You can just find it out here. The maximum value of it is going to be a2 plus a1. If you take these things, a1 and a2 is equal to 1, so it will be the normalized. Alright, so this is the discussion, and I just hold it here, and in the next section I will be just doing numerical, or I'll just let me see if I have some time left, so I can just do it here. I do it here, so I just bring up the book here and show you. Okay, one thing which is still remaining is the underdamped case, so we will be just doing it later on, but we can just solve the numerical here. That is a example problem 8.3. So just to find out the putting in the values of R and L in place of alpha and omega. So we find out the roots. So these roots come out to be minus minus. They both are minus. So that means alpha is greater than omega naught. We conclude that the response is overdamped. Right. So from this point on, you can just solve this problem, practice problem 8.3. So for the case of next thing and the damped case, I will just recording one more lecture number 30. So till then, bye for now.